let's talk about Green theorem, which is applicable for 3D. In 2D, for 2D we talk in next video. So our Green theorem is based on Gauss theorem. Since we talk about is the Gauss theorem previous class theorem. Okay, so now we talk about the what is the Green theorem. It says that how can we convert the volume integral say phi square sine and plus divergence phi into phi into divergence of sine, which is equal to surface integration of phi divergence sine into ds, or here it is dv. And we talk about in first form, and second form we also talk in next video. So let's prove what is this. So we know that the using of Gauss, already know the Gauss theorem. Now we talk about how to solve it. First of all, we say A is equal to one second. So first of all, we talk about some important thing. I miss the important thing are here the psi and phi are all scalar functions. Scalar function. What is the vector scalar function? We talk about in next video. So we know, once again we know about the Gauss theorem. The Gauss theorem says that how we convert the integral theorem in the volume integral into the surface integral. So divergence a dv, which is equal to surface function of a into ds. So here let's say a is equal to for example phi delta divergence psi. Okay, so if a is equal to the component form, we say axi plus of a y z cap plus of a z k cap. Okay, so it become phi del x into sine I cap plus del y sine z cap plus del upon del z sine k cap. Okay, now let's say simple once again what this. For ax it become phi del upon del x sine, and ay it become sine dy into phi, and for az it become phi d upon dz sine. Okay, so we know that the divergence are, what is the divergence we talk in we already talk about, it is dx upon ax plus of means divergence are the whole whole partial equation we talk about in 3 dimension same time differentiation in all direction we talk about in already in previous classes. So this is dy and dz az. Okay, so if we put the value, so we get d del upon del x into phi d upon dx sine. That was great. This is dy upon dy and phi d upon dy sine plus d upon dz z sine. Okay, now it become d upon dx phi into d upon dx d sine, chain rule, and now become phi d upon dx square sine. Okay, same using chain rule is also applicable to chain rule. We are talking vector calculation video. This is d phi d upon d sine, and also plus of d upon dy square sine into phi. The vector calculus we talk about what is this. Okay, dz phi d upon dz psi, and also become this is d upon dz whole square psi and phi. Okay, now take this all same time, so it become d upon dx phi into d upon dx psi plus of d upon dx dy phi into d upon dy psi plus of d upon dz phi into d upon dz psi, and plus of same it is d square phi upon dx into phi plus of d upon d square into dy psi into phi plus of d square dz psi into phi here. So it become, so overall it become phi and psi. Overall this has become this multiply, and plus this become whole part become phi into Laplacian square, this is Laplacian psi. Okay, so if we put, so this is the all value, this is the all values of divergence of A. So let's put this all in equation 1. Say what is phi delta is Laplacian square psi plus of gradient phi, this is divergence psi. Okay, and put in equation 1. Our equation 1 is triple integration of divergence of A, this is phi square psi plus of phi into del Laplacian also gradient, and which is equal to surface integration of A, which is phi this psi ds, and here it is dv. So this is the our first symmetric of Green theorem. Okay, this is our equation 1 here it is our equation 1. Okay, so this is the overall Green theorem, which is very beautiful. So, and here is the constant scalar function. In next video we talk about the second form of, and the for 2D we talk about the Green theorem for 2D. I hope you understand. If you understand, like and subscribe.